Hi there, let's go over the answers to these matching. First, let's just get rid of this one because we didn't really talk about it. So the total mass of a substance divided by the total volume. So that one would be the average density when we're talking about total. Okay, it also could be density. So either depends what you're dealing with. More than one substance, then you add them up. Here's when gravity equals buoyancy. That would be neutrally buoyant, like our grape. We made our grape in the salt water neutrally buoyant. It didn't sink and it didn't rise. A property that describes a liquid's thickness, that is viscosity. The pull of gravity on a mass, we call that the weight of an object, and the weight basically varies depending on the size of the planet. Space occupied by an object is called the volume. The opposite or opposing force to gravity is called buoyant force, and anything that causes a change in the motion of an object, we call that a force. Let's keep going. How would we make plastic sink and steel float? Well, we change the shape of the object. So, for example, plastic, if we roll it up into a tight ball, we can change its density and make it greater than 1, and it will sink. And steel, if we change the shape of steel and we make it nice and thin with lots of room to have air in here, we can adjust the density of the steel so that the air helps make it float. Archimedes' principle. Well, here it is in words. Any object wholly or partially immersed in a fluid is buoyed or pushed up by a force equal to the weight of the fluid that the object displaced. Now that's a mouthful. So let's look at this. If we put a bottle like this, according to Archimedes, it displaces or pushes away a certain amount of water right there. So there's the water. The weight of that water, so we can take a scale, a spring scale, and we can measure in newtons the weight of that. So it pushed away this water. Let's say that it weighs 10 newtons. Well, that's how much buoyant force is acting on it. Let's say the bottle was only 1 newton. Then what would we know? It would float because 10 newtons is the buoyant force. The pull of gravity is only 1 newton. Let's look at now a different situation. Here's the bottle again. How much water it displaces is this much. So we take this water that it pushed away and we measure it, and it's 10 newtons. So the pull of gravity is 10 newtons. Now we've got steel in there, or rocks. So now the downward force of gravity is 9 newtons. The upward push is 10 newtons, the buoyant force. So it still floats, just barely. Okay? And now if we put more rocks in it, and so now the pull of gravity is 12 newtons, and the amount of water it displaces is still 10 newtons, it sinks. So negatively buoyant, neutrally buoyant, and positively buoyant. Let's keep going. Make a label diagram to show most important design feature of a hydrometer. So you're making a hydrometer right now, and here are important design features for you. The hydrometer has to float. Not only that, but it has to float upright, and it can't lean over. Next, it has to have a scale on it so that you can record the density of the fluid or specific gravity. So the density. Okay, so once again, it has to be able to float. It can't sink. It has to be upright, and it can't lean against the sides of the walls of the container. It has to have markings or a scale on it so that you can record the density of a fluid. Part 2 coming up next. I'll go over question 4 and 5 in a few moments.